Last week, we explored the essential preparatory processes for constructing the underwater design Canary Wharf station, focusing on the cofferdam. This week, as previously mentioned, we'll delve into the construction phase that follow the cofferdam installation, specifically the post-dewatering works. This new chapter begins as a continuation of last week's discussion, focusing first on temporary support system used in the Canary Wharf cofferdam. To construct the cofferdam, two methods were proposed. The first involved building a cofferdam using double steel sheet piles and an additional cut-off wall, allowing for construction under relatively open conditions. The second method used Gießen tubular piles pressed into the Lambeth clay, which were then extended upward as reinforced concrete retaining walls. The first approach required dewatering a very large area, making it less efficient. The second approach required temporary support structures. Traditionally in underground construction, this support comes in the form of props, horizontal struts installed across the excavation to brace the walls. However, since these props occupy interior space, they interfere with construction access and sequencing. In the Crossrail project, due to the contractual constraints, the station box had to complete it before the TBM passed through, making construction speed critical. As a result, the design team opted to install the temporary support externally rather than relying on interior props. Accordingly, additional single anchor piles were installed outside the cofferdam formed by Gießen piles. The cofferdam was tied back using the tie rods to 160 single anchor piles spaced at 2.92 meters. Each anchor pile had a diameter of 1.2 meter, thickness of 14 mm, and a length of 18.5 meter, and was installed from the water using conventional piling equipment. This setup allowed the cofferdam to withstand water pressure without internal props, as the walls were externally supported. If dewatering had been carried out in this state without further measures, the pressure difference between the inside and outside would have caused the cofferdam walls to deflect inward. To prevent this, a pre-stressing process was essential, applying about 100 kN per meter of force in advance via hydraulic jacks to the tie rods connected to the anchor piles. This differs from conventional methods where pre-stressing is applied via internal props. After pre-stressing, safe dewatering was carried out. Once the dock was drained, the site was cleared and residual silt inside the dock was removed to establish a dry and stable working environment. Now that the site environment was ready, full-scale construction could begin. Before major works commenced, 30 plinth column piles with a diameter of 2.1 meter were installed to a depth of 14 meters along a common centerline. These piles provided temporary support for the top-down construction and long-term resistance to groundwater uplift. During the top-down construction, where slabs are built from the top down while excavation proceeds below, the planche columns temporarily support the upper slabs. Their role was crucial for immediate load bearing during the process. Once excavation is complete and permanent columns are installed, the structural load is transferred. Planche columns are typically installed in the location of reinforced concrete columns. Eventually, they become integrated with the permanent structure, serving both as temporary support and part of the final framework. After piling work was completed, construction using the top-down method began. The top-down method involves constructing the upper slab first, then excavating downward floor by floor while simultaneously building the structure. This method has the advantage of structural stability as the slabs provided intermediate horizontal support to the retaining walls, minimizing lateral deformation and settlement. This was especially suitable for Canary Wharf Station, where additional horizontal support was needed despite pre-stressing, due to ongoing deformation during piling. The first level constructed using the top-down method was basement level 3, the closest level to the dock bottom after dewatering. In fact, it was located about 2 meters below the dockbed, and the excavation marked the start of structural works. After the excavation, the construction of the slab on the basement level 3 proceeded simultaneously with the excavation and foundation work for the lower floors. The nature of the top-down method allowed construction on basement level 3, 4, and 6 of Canary Wharf Station to take place simultaneously. On the sub-level 3, equipment installation and finishing works were being carried out. On the sub-level 4, slab construction was underway. And on the sub-level 6, excavation and foundation work were taking place concurrently. As a note, the sub-level 6 was the platform level, which required the passage of the tunnel boring machine. If the structure of sub-level 5 were built first, the TBM would risk damaging the sub-level 5 structure while passing through. Therefore, the TBM passed through first and the sub-level 5 was constructed later. As a result, this construction approach accelerated the progress of Canary Wharf Station and ensured that TBM's workflow was not disrupted. Due to the contract with Crossrail, the structural work needed to be completed in advance to allow the tunnel boring machine to pass through the station interior without issues by mid-1220. According to this, the external station box structure, slab work above and below excluding the TBM passage area, and the formation of entry and exit openings for the TBM were all completed by July 2011. Thanks to this preparation, the TBM was able to pass through the station on schedule. Moreover, as the top-down construction was already underway and the station box was in place, the TBM did not need to perform any additional excavation. Instead, it simply had to pass through, assisted by lifting brackets and cranes, as mentioned in the previous presentation video. After the top-down construction, the floors that did not require excavation, such as sublevels 2, 1, and 0, were constructed in sequence. Once the construction of these floors was completed, pre-stressing was no longer necessary, and a process called distressing was carried out to release the forces acting on the tie rods. At this point, the station structure was complete and the temporary support structure was no longer required. Once the upper floors up to level 0 were finished, and after the TBM passed, sub-level 5 had to be constructed. However, an important issue needed to be addressed at this stage. Since the upper floors were already covered, a solution was needed to bring the materials for the platform floor down to the basement. This challenge had been anticipated during the planning phase, so a space known as mole hole was pre-planned and drilled inside the station structure to allow for materials to be lowered to the basement. There was only one mole hole in Canary Wharf Station, and it was the only way to transport materials. Due to the size limitations of the hole, 550 precast concrete slabs were lowered through it and assembled in the basement. Additionally, panels for escalators were also lowered through the same hole. With the structural construction of all floors, including the platform level at Canary Wharf Station, now completed, it was time to begin the finishing work and installation of the systems inside the station. The construction of Canary Wharf Station not only impacted the station's interior, but also the surrounding environment. One significant example is the Great Wharf Road Bridge. This bridge, measuring 68 meters in length, 24 meters in width, and 10 meters in height, spanned the North Dock and formed part of the northern connection to Canary Wharf Central area. The bridge's piers were raised 18 meters high by a massive hydraulic ram, creating a 15 meter by 15 meter navigation space. However, as the Canary Wharf Station was being constructed, the passage through the North Dock became significantly narrower, necessitating the shortening of the bridge length. As a result, the bridge was demolished, and a new 26 meter by 22 meter new upper bank street lifting bridge was built in its place. This week, we focused on the structure of the entire station before the main interior work began, primarily exploring the top-down construction method. Next week, in week 9, We'll discuss the rooftop garden, roof structure, and materials used for the roof. In weeks 10 and 11, we'll wrap up the series of presentations by covering an overview of Canary Wharf and providing a comprehensive story of the selected building.